Hello everyone, welcome to 369 Chemistry, and in this video I'm going to talk about epimers and anomers and what is the difference between your epimers and anomers. There is a similarity, people get confused. So what is the basic difference and how we can differentiate it? Okay, so now what are epimers? See here, these are pair of diastereomers, okay, they which differ in the configuration about a single interstitial carbon atom and are called your epimers. Okay, so if you take molecules like this, so these are all sugar molecules. So whenever you have carbohydrates, okay, and see, whenever we find configurational isomers, we see about your chiral center. Chiral center means the carbon atom which has all different the four hands has been replaced by your different atoms. Okay, so these are called your you can say a chiral carbon. So here the chiral carbon center is your C2 carbon. See here, C1. Okay, there are 2 3 4 like this. If we would count it, there are 6 carbon atoms, so it's a glucose. Now see, around C2 molecule, all others, if you see C3 C4 C5 C6, all are same. If you see here, all is same. The position of OH group and H is also same. It looks similar, but only there is a difference between your C2 carbon atom. Okay, so in the first one, it is your OH group is on the right hand side, so it is plus glucose. Dextrorotatory, it rotates the light clockwise direction. And you see here on the second molecule also, the OH group is on the left hand side, so it is forming also a mirror image, but only on the C2 carbon atom. So there is a difference, you can say, only on one carbon atom. Okay, and it is between the two different molecules, not on the same molecule, two different molecules. If you are taking the pair of diastereomers, these are all diastereomers, means what? If you superimpose on each other, they do not form mirror images. Okay, so these, if they are forming mirror images, we say it to be enantiomers. If they are not forming any mirror images, we say, or we call it to be diastereomers. Okay, and here see, the difference is only with one carbon atom. That means only C2 carbon atom there is a change. So that's why we say it is epimers. So only one carbon. It can be C2 C3 C4 depending on the molecules. So the first example I have given your glucose and mannose. Okay, these are all aldehydes. Other example is of alcohol. 2 OH group is present, so it's sorbitol and mannitol. Now we were going to talk about your what is anomer. Okay, anomers are basically pair of diastereomers that differ only in configuration about a single terminal and are called your anomers. Okay, and the ring form of the glucose are your anomeric forms. So anomeric ring form will be anomeric, whereas the open structure is not anomeric. So if you write the ring structure of the glucose, how to write the ring structure of the glucose? See here, you draw a hexagon, okay, and there is an oxygen group out here, and the left hand side of the oxygen ring is this fifth carbon. We consider that with fifth carbon. It has a CH2 group, CH2OH group, and that you have to write as a principal one, CH2OH, and the other one is H. Now this H will be in the next one, H will be above, OH will be down, and the other one, OH will be come up and H will be go down, and then opposite again, H will come up, OH will be coming down, and then now here see, OH should be in the above side for the first structure, but here the OH is on the you can say a downward position. That means this is your C1 and C2. So the difference is C1 and C2, the terminal, these C1 and C2, this is the one terminal, and here OH is on the same side of the terminal, so we are going to say it to be alpha anomer. Whereas in the second structure, you see OH is on the opposite side of the same terminal. That means C1 and C2, the terminal, if we consider, the OH group is in opposite direction. One is in downward, another one is above the ring. So this is called, first one is called your alpha form of the anomeric form, and the second structure is called your beta form, where both OH is in opposite direction. Okay, so this is your anomeric form. Now we come to the differences. In epimers, we consider pair of two diastereomers and we check only one carbon atom, whereas in case of anomer, we are checking the two terminal of the carbon atom, that means C1 and C2, and then we are checking both OH group are on the same side or opposite side, and that is gives your anomer, whereas in case of epimers, it is only one single interstitial carbon atom.